Alright, so today we're going to be going over the review of trig derivatives. So essentially this is extension off of derivatives, and this is just mainly focusing on trig functions. So I'd say these three derivatives here, sine x and cosine and tangent, are really important to know. Secant, cosecant, cotangent, they are still important to know, but you could still you could kind of like produce these derivatives without memorizing them. Like secant x is going to be 1 over cosine x, and just use the quotient rule and you're gonna get secant x tan x. So you could kind of just rely on finding out the derivative manually instead of memorizing it, but these three trig functions you kind of always want to know. So let's get to some questions. Alright, so first of all, we have 3 sine x minus 2 cosine x, which we just use trig derivatives. It's going to be 3 cosine x minus, or actually plus 2 sine x, because derivative of cosine is going to be negative sine, and 2 negatives is a positive. Now number 2 is going to be tan x minus 4 sine x. The derivative of tan is going to be secant squared x actually, minus 4 cosine x. And then we have x squared plus cotangent x. So derivative of x squared is going to be 2x. And if you remember, the derivative of cotangent is going to be negative cosecant x squared. And then now we have number 4. Number 4 is 2 secant x. The derivative of secant x is going to be secant x tan x. And then the derivative of negative cosecant x, or rather cosecant x, is going to be cotangent and cosecant x. And that would also be a negative, which means that we have two negatives. So that would just be end up being a positive. So that would be our derivative. And then for number 5, we have theta and then sine theta. Just for like visualization purposes, sometimes you could write theta as like a variable, like x squared and multiplied by sine x. But we could leave it as theta. So for this, we have to use the power rule because they're being multiplied. So we have f, which is theta squared, and then g, which is sine theta. So f prime is going to be 2 theta multiplied by g, which is going to be sine theta, and then plus theta squared, which is going to be f theta squared, multiplied by sine squared, which I mean sine derivative, which is going to be cosine theta. And if we multiply it out, we're going to have 2 theta sine theta plus theta squared times cosine theta. And that would be your final derivative. And now we have number 6. Number 6 is going to be a little bit the power rule and power and the product rule. So for 3x, we could just use the product rule. That's going to be 3. And then for x squared plus cosine, we have f as x squared and g as cosine. So we're going to have plus, and then f prime, which is going to be 2x times g, which is going to be cosine x, and plus f, which is going to be x squared, times g, which is going to be, or g prime, which is going to be negative sine x. So we could rewrite this as 3 plus 2x cosine x and minus x squared sine x, because we have negative sine x and that negative sign carries over. So that would be our derivative right there. And now at the end here we have secant times tangent, and now here we have to use the power rule, which is going to be f prime g plus fg prime. So f is going to be secant, g is going to be tan. So f prime is going to be secant, and theta, I'm actually going to replace that with x just because theta's, it's going to take me forever to write it. We have secant x times tan x, and that's f prime. Now we have f, which is going to be tan x, and that's going to be multiplied, or actually added to secant x, multiplied by the derivative of tan x, which is going to be secant squared x. And now if we add all this or simplify it all out, we're going to have secant x tan squared x plus secant cubed x because we have a secant and then a secant squared x. And that would be our final answer. Alright, so we're going to move on to these few questions. So we're going to be dealing with a lot of product and then quotient rule. And one of the questions we use the chain rule for, or rather the power rule. So number 8 is going to be the product rule. So we're going to have sine and cosine. Sine being f and then cosine being g. So we're going to have cosine x times g, which is going to be cosine x. And I'm going to replace data in all these questions with x just because it's easier to write. But normally when you have a question in terms of theta, you kind of want to have the derivative and whatnot in terms of theta. So then we're going to have plus sine, which is going to be f, multiplied by derivative of cosine, which is going to be sine x. If you find this or add everything together, you're going to have cosine x minus sine squared x. And that is going to be your derivative for number 9. So number 8. Number 9 is going to be theta minus cosine theta times sine. Now what we could do is multiply it out, but the problem with that is we're gonna have to use the power our product rule twice, and we're way better off not doing that. So if we rewrite this, we're gonna have this would be like x minus cosine x. So x minus cosine x would be our f, and then sine would be our g. So we're gonna have 1 minus or 1 plus sine x is derivative of sine or cosine, and then we're gonna have g, which is sine x, and that's gonna be added on to x minus cosine x times sine or a derivative of sine, which is gonna be cosine x. If we multiply it out, we're gonna have sine x plus sine squared x, and that's gonna be added on to x cosine x and minus cosine squared x, and that would be your final derivative. And we're actually going to skip number 10 because it's kind of like the same thing as number 9 exactly, except just with tangent. Now number 11, we have cosine squared t, in which now we can use the chain rule. Our outside function would be the squared right here. So we would bring the 2 to the front, so we would have 2 cosine t, and the 2 exponent would turn to 1, but we could just leave it as cosine t, multiplied by derivative of the inside, which is cosine t. Derivative of that is going to be negative sine and t, and that would be your final answer. And now we're going to skip number 12 as well. That's also kind of the same thing. We're going to move on to quotient rule ones. So we have number 13. Remember the top is f, bottom is g. So the derivative of f is going to be cosine x multiplied by g, which is going to be 1 plus cosine x, and then minus sine x times the derivative of g, which is going to be negative sine x. And that's going to be over g squared. We'll write out g squared later. So if we multiply this out, we're going to have cosine x plus cosine squared x minus, or actually plus sine squared x because we have a negative sine x over here. And we can't simplify this any further, so we're going to write out the g squared, which is going to be 1 plus cosine x, and we'll square that. And obviously, you instead of x, you want to write theta for your real questions and answers. And now let's try number 15. Number 14 is like exactly the same thing. So let me free up some space for number 15. So number 15, we're going to have x over 2 minus tan x. So if we're going to have to use a quotient rule here, so we're going to have f as x and then g as bottom. So f prime is going to be 1 times 2 minus tan x, and that's going to be subtracted to x, which is f times g prime, which is going to be negative secant squared x, and that's going to be over g squared. We'll write out g squared later. So if we simplify the top, we're going to have 2 minus tan x, and that's going to be plus x secant squared x, because we have negative and then a negative over here, so that would be plus. And we can't simplify this any further, so we could write the denominator, which is going to be 2 minus tan x, and that's going to be squared. And that is our final derivative for number 15 using the quotient rule. Alright, so now we're going to move on to these few questions. So this is what I was talking about earlier, in which you really don't need to know the derivative of cosecant, secant, or cotangent off the top of your head, because you can always just calculate it using the regular trig function derivatives. So let's do that real quick by hand, just so we could, um, make sure that we could find out the derivatives of these by hand if we need to. So we know that cosecant is going to be 1 over sine x, and then sine or secant is going to be 1 over cosine x, and then cotangent is 1 over tan x. So we can just write that out. So we're going to find out cosecant first. So we're going to have 1 over sine x and d over dx, which this is the same thing as cosecant x. So we're going to use a quotient rule here. F is going to be top, g is going to be the bottom. So f prime is going to be 0 times g, which is going to be sine x, and that's going to be minus f, which is going to be 1, times derivative of g, which is going to be cosine x, and that's going to be over sine x squared, or yeah, sine squared x. We could just write it like that. And if we simplify top, this goes away, so we have negative cosine x over sine squared x. And when you look at this, what does it exactly look like? We could break it up into two things, right? We could break it up into, if we break it up, we have negative 1 over sine x and multiplied by cosine x over sine x. So if you look at it here, what's cosine over cosine over sine? Cosine over sine is going to be cotangent because it's the opposite of tangent, or tangent flipped. And then 1 over sine is going to be cosecant. And we also have our negative sign here, so which is going to be that negative. So we just proved that, or we just actually showed how to find the derivative of cosecant without actually knowing it by hand or by head. So let's do the same thing with 1 over cosine. So we're going to find the derivative of secant x. So we just fg, and then we do the same thing. So f prime is going to be 0 times cosine x, which is going to be that, multiplied by f, which is going to be 1 times negative sine x. And on the denominator, we're going to have cosine squared x. And if we remember, this goes away. So we're going to be left with sine x, because we have two negatives, so that's a positive, over cosine squared x. And now again, we could break this up. So if we break it up, we're going to have 1 over cosine x multiplied by sine over cosine x. So again, what's sine over cosine x? Sine over cosine x is going to be our tangent, or tan x. And then 1 over cosine x is going to be secant. So we just proved the derivative of secant. Now let's do the same thing for cotangent. So cotangent is going to be a little bit more complicated. So cotangent is going to be 1 over cosine, 1 over tangent, but instead of 1 over tangent, we could just do cosine over sine. Any form works, but I would prefer 1 over or rather I would prefer cosine over sine just because 1 over tangent x will get a little bit more complicated. So we have cosine over sine. So cosine's going to be f, sine's going to be g, and so we're going to have f prime, which is going to be negative sine, multiplied by g, which is going to be sine, minus f, which is going to be cosine x, multiplied by derivative of g, which is going to be cosine x, and that's going to be over g squared, which is going to be sine squared x. And if we simplify the numerator, we're going to have negative sine squared x minus cosine squared x, and that's going to be over sine squared x. So now let's erase this part right here so I could write it out. So this is one good rule to know if you don't know it yet, but it's gonna be sine squared x plus cosine squared x is always equal to 1. So we can apply that rule here. If we factor out the negative, we're going to have plus and then sine. We just put that in parentheses. So we have sine squared plus cosine squared x on the top. What does that mean? That means that the top is equal to 1. So if we rewrite it out and add it in, we're going to have 1 over sine squared x. And it seems a bit complicated at first, but this is like the general consensus of how we just replace sine squared plus cosine squared x. And now, if you look at it, we have negative 1 over sine squared. What's sine squared? Sine squared, or 1 over sine squared, is going to be cosecant. And 1 over sine squared x is going to be cosecant squared x. And then we have the negative here. So that's going to be 1 over sine squared x. And then we have the negative right here. So this is the derivative of cotangent is going to be a little bit more complicated, but as long as you know the rule of sine squared x plus cosine squared x equals 1, it should be pretty easy to figure it out. Alright, so that was basically a review of trig derivatives. Derivatives of like trig functions in the product rule. I think we did some chain rules, some quotient, and as well as how to prove secant x, cosecant, and cotangent, and how to find the derivative without actually knowing these. Personally, I've never memorized these. If I've ever needed to use them, I just do it by hand. But sine x, cosine x, cosine negative sine x, and tan secant squared x are three derivatives that you need to memorize. So yeah, that's basically it.